The opening, or I can make a pre-made cover already. Cut a cardboard and just cut an opening for my duct blaster there. So what I'm going to do is use my duct mask tape to cover the opening. And basically all I'm going to do really quick is just take this. And this is easy tape to use, doesn't take long to do this. Just cover over the top. And I think we did this during our class.
We did.
Heating class.
We did.
Yeah.
What type of tape is that?
This is called duct mask. M-A-S-T. And they should, I believe, yeah, they have it because we use these. This cover goes over it as well, so I'm just going to put it right there.
So instead of a frame, you have to build it out of
Yeah.
mask. Okay.
Because I don't have already I could have a pre-made one, but we don't have time for that right now.
Ain't nobody got time for that.
So I'll just make one out of the tape. The key is to make sure that it's...
Why can't I do this with the blower door?
What's that?
Why can't I just use this stuff when I do the blower door test?
Use what stuff? I don't follow.
The mask. Just build a little frame around it instead of...
You mean make a pre-made one like the blower door?
Nah, just what you're doing across the door though, and just put the blower door in there.
Okay, I don't think that's going to hold up on you. Right, just take a look if you want to see how I just taped that up nice and
Let's
tight.
get in there and
Everybody, all sides, no air, top and
No
bottom.
air.
All the way around.
Channel, you know,
No.
Alright.
automatically done when the video
Oh, let me get the Tom's
Oh yeah,
PSEMG light.
They have
Tommy will appreciate that.
Everybody just watch.
So if there's a little bit of leak, there, it really doesn't make any difference.
I mean, probably
Because
not,
you're pushing
but,
everything in, so you
yeah.
aren't measuring anything down there. So
But the duct system is not totally sealed, and I'm getting leakage around that spot where it's open up, where it should not be. So now, what I'm going to do is hook my duct blaster directly to the plate here. So I'm going to put this to the side.
That was gonna happen.
And that just goes on there. That's set.
Blower door's way easier than this.
Yeah, it is. Now I have set up my power supply cord here, and there's a 3-prong adapter that fits in here. 3-prong. This is female, the 3-prong male on this side. So you just have to match up the prongs and just tighten.
I'll do that
And it's
first.
set. Okay. I guess everybody knows where this part goes, right?
Yeah.
Yeah. All right.
bend over.
Yeah.
You know, he said.
Okay, here we go. Outlet right here.
Don't get zapped.
Yeah. Let's see if the power's on this.
Any VOCs in here? No? They got rid of them?
Yep, those they took out.
The
VOCs, the paint.
There's like
everything
paints
should be
and
down here.
paint thinner and
Okay, so that part of it is done. So now, what else I got to do?
I don't know.
Hook up the manometer.
Hook up the hoses and all. So how do we do that? How do we go about doing that?
So I'm hoping you can tell us.
So
You put that
here we go.
this thing into the supply, the one with the hook.
Okay, let me show you how to get it easy on the manometer. I don't think that he gives you no setup secrets on your thing, right?
I don't think so, but that's why we're taking this cheating video.
So
Oh, he does.
he does what he said. He does. Okay, good.
Duct blaster.
Oh, good. Okay.
You get a little hook up.
So, as I mentioned to you before, the manometer is a channel A and a channel B. Channel A just measures pressure. Channel B measures flow and pressure. So, what I'm measuring with the duct system, I want to know what's the pressure inside the duct system.
So that's B.
All right. So, I'm going to, what side is my channel A is going to be hooked up? If I want to know I'm going to set my pressure in the duct system at 25 pascals. And then I'm going to measure that flow, the airflow through the duct system. So channel A is going to be hooked up to what?
Supply.
All right, good. Channel A will go to the supply side of the system.
And does the color of the hoses matter?
No.
Which one we do to
Just
which?
no.
Okay.
So channel A, I'm going to put Now I have two choices: input or reference. Where's it going to go?
It's going.
In,
Oh, I don't know.
input? No. No. Wait a minute.
I don't know
It's,
what we're
with
testing
reference to the-
necessarily.
I think you
So
take
it
that
goes into
supply,
the
right?
input.
Okay,
with
what I'm going to
reference
do
to-
is I want to get the duct pressure to 25 pascals and measure what that airflow is at a 25 pascal pressure, duct pressure.
So that's your reference.
Positive pressure. My reference is what? No, my input is 25 pascals, and I'm referencing that to the main body of the house or wherever the duct blaster is located.
So you're putting it at the top.
Put it at the top because I want my input pressure inside the duct system to be 25 pascals.
With reference,
That's
with
where you're-
Reference to the main body part of the house. Main
So,
body of
so is the
house.
reference staying open?
Reference will stay open.
Okay. And this is all on channel A, the left side.
Channel A is my pressure side of the system, so I'm going to put that on the return supply side. And I don't remember where we placed it the last time. Does anybody?
There you go.
It doesn't. Okay.
Use your screwdriver, poke a hole in there. Your screwdriver's over there if you're still looking for it.
There's some
Where?
duct tape
It's all
over
in the,
here,
Oh,
maybe.
I had a drill right in here that I could pop it.
There was a hole in
I don't
here.
even know where we
I thought
placed
you
it the
had a
last
hole
time.
where
I
we-
thought you had to
we
do it
did.
closer than that. Don't you have to do it closer than
Yeah,
that?
this would be closer to the
It
plenum.
does, but I don't see a hole.
I
It's
thought
normally.
we'll put
There's
one in
one
I
there.
don't
up
have one
here.
up. Where?
There's one up here above the air conditioning coil. which-
That would work.
No, that's a stag. Let's try. This is good. This is good. We'll see what we get, and we'll test another spot. 'Cause this is not far. This is not very far from the system.
So we're not going to fail if we end up testing here.
No. You're gonna fail if
I got you
put
covered. I've been videotaping the whole thing.
You're gonna fail if you put it in the return, but you have it in the supply. And this should be faced in the direction of the airflow. So if I'm blowing air into the system, which direction is the air going to be going?
Oh, it's going that way, but we're
So
going to
this
face
should
it the
be
opposite
in
way.
the airflow. All right. So if the air's coming this way, should this be going there or there?
That way.
Going here. So that
Okay.
towards the airflow. All right. So now I got my channel B side. Where's channel B going to go?
Return.
It's going to go
I got my channel B. So I want to measure.
the bottom.
I'm measuring duct pressure at 25 pascals, and I want to know what the airflow is at 25 pascal duct pressure.
Reference to the B side on the duct blaster.
All right, good. I'm going to place it on the duct blaster. That's where this goes, to the
Right.
duct blaster, because that's what's
Right.
measuring airflow in
Right.
CFM.
Right, you're going to put that on there, and then you're going to go to the manometer
And where's this going to
at the
go?
bottom.
No, it's going to go at the top, input. I think it goes, on that sheet, I think he kind of outlines it, right? Didn't you guys say that?
Can I get a
Yeah,
view
both
of
the
that?
top, right? It says the B side top duct blaster.
Yeah. B-side top, duct blaster, there you go.
Okay.
That's how the
Okay.
setup should be. Okay?
Okay, so there's no reference.
Now, since I'm not going to turn this on yet because I don't want to run my batteries down, I still got some more work to do. I'm not quite ready yet. What else do I have to do?
Return.
Not quite ready for prime time yet.
You got to go seal
Ready?
everything upstairs,
All
right?
right, what else? I'm missing something big right down here.
We have to check our.
Filter.
Good, exactly.
CO?
What about the filter?
Have to
Check and
take
see
it
if
out.
it's clean?
Well, check it.
Right.
Don't you take it out?
Exactly. Why?
Because it
restricts.
restricts flow.
Exactly. So I need to take it out.
But you have to tape it too, right?
Well, they got a new one.
Now-
It still
now-
doesn't fit.
No, but at least it's clean. Yeah, so give them some credit. You don't give them credit for nothing, do you? Now
They
what
didn't fix the
about-
stairs you fell down.
Yeah,
You have
exactly.
to tape it, right?
Good. I have to tape this.
Ah, to cover the flow. Yeah, right.
Yeah.
Because this is part of the duct system as well.
And I don't know. You guys know some advanced stuff. When press heating guys, man. Future.
Yeah, there's a lot of studying. To pass the heating written test was ridiculous.
The written test was-
Crazy.
I literally took off 4 days to study for it, and I studied all 4 days.
For the written test?
Yeah, and I just still didn't do that well. Yeah,
Yeah, what'd you get?
got like a 74. I passed barely.
I got a 75.
Because
Yeah.
the heating is tough. It's a lot more you have to learn
Yeah,
for
yeah.
heating. I mean, you got tons of different heating systems. All right, now, what else do I do now?
We got a seal upstairs.
There we go. So let's go.
Alright.
And I'll let you guys do some practice on that.
So,
Crab cakes are good.
So that one is by the stairs. We have a return over here. Larry's working on. Is there any more besides this?
Yeah, all the ducts, all the supplies.
Do it down on the bottom first.
Yeah, just lay it on here. Put it down. Separation.
All right. Okay, so the duct blaster is actually pulling
No, it's blowing air
pushing
into the
in.
duct system.
It's
I'm
pushing
putting
in
a
air.
positive pressure of 25
pressure.
pascals on the duct
boy.
system, and I
Through
want to
the
know what is
Okay.
the flow at 25 pascals.
Okay.
Let's just make sure that it's running.
No, what I'm trying to find out how leaky the ducts are. Total duct leakage.
Because of how much flow you measure.
There's an additional one in the kitchen here.
Will be on YouTube, Chris Pagodin.
I probably will upload it just so we have it. That's probably the easiest way, if you guys want to watch it, to do that.
Yeah.
Talk to me the knowledge. You need 2 to be certified, and then they allow you to do additional things, or
Another one up here.
Cars there. Were there any others? That was just.
I don't know,
the
you gotta
one
tell
there?
me, tell me.
So far we have one in that bedroom, one in that bedroom. We're not sure if there's any more.
Was there one in the bathroom?
I looked, I didn't
There's
see
no heat in
one.
the bathroom?
I don't know, you can double check, but I didn't see one.
What does the sheet say?
I don't know.
they put mine downstairs.
Alright, well, wait until we're down. Could put a real damn handrail on this freaking thing.
This together. What did you guys do? You started.
So I got the whole thing on video. I'll give it to
doesn't
you.
matter. Just start taping. And any place you want to start, you can just. This has to be taped on. Just start putting the tape on. Boom, just work your way. I just started.
We call
look at
this
that.
partly
Look
sealed,
at
or
that. Wow.
we call this partly sealed.
What partly sealed? Well, the duct work is partly sealed. It's not quite sealed.
Not
you can
fully,
see.
right, yeah,
You
right.
can see plenty of leaks and stuff like that. I have the house. The house is set up properly. Duct system is. What else does your sheet say? I don't have mine with me.
Yeah.
Did we cover all the areas so far? Let's see. Duct blaster. Manometer set up. Okay, appropriate. So your duct blaster set up appropriately, is it?
25.
So far, duct blaster set up.
Let's return tap.
Manometer supply. Return tap appropriate. Yep, this is my. Yeah, this is the return side tap. Is that set up appropriately on this side?
Okay.
And our supply side tap is set up appropriate. A side to trunk line, B side to duct blaster. Is that what we have? Is that our setup?
Mm-hmm.
Okay. So now let's turn on the duct blaster. I mean the manometer. So I'm going to turn it on. Automatically, you know it defaults to pressure. So what I need to do is, I don't have to get a baseline on this. I don't have to worry about that baseline feature. So I'm just going to put it in mode. Pressure and flow is the mode I want because I want to measure pressure and duct flow,
At 20,
airflow.
At 25.
Yeah, yep. We're going to question.
I just know for the blower door, it's what's it's 1, 2, 3, right? It's a
Yeah,
baseline.
it's a little bit different
Right.
on that one. So I want pressure and flow at 25. So I can press again mode. That's first I'm going to go pressure to flow at 50. Pressure to flow at 25. So that means that it's going to get a duct pressure of 25 pascals. And it's going to measure what the airflow is at 25 pascals. Next thing is I have to set up the device. Now, right now it defaults to BD3, and that stands for what? Blower door Model 3.
Right.
So is this a blower door I have
No,
set
it's
up?
not. It's
So I have
so
to
you
change
want-
it to, if BD, so I have to change this to DB, duct blaster. And this is a Model B. This is the model you're going to be using,
Model
duct blaster
B.
Model B. And I think it says that here. No, probably doesn't look like it, but it's going to be duct blaster Model B.
Model B as in boy.
Yep. Now I have to decide what configuration am I going to run in it. Am I going to run open? Am I going to put a ring A on, ring B or C? And it comes with 3 rings or open. I'm probably going to run, it's not a large system, it looks kind of leaky. I'm going to start off with an open configuration, meaning I'm not going to put a ring on it. Right now I have ring 1 on it, but I'm going to take that ring. Matter of fact, I'm going to run it with ring 1. So I'm going to try it like that, because this is a small system. It's not a big house. It's a small duct system. Even though it's leaky, the duct system is pretty leaky, but the house
So the
is small.
smaller.
The tighter the duct system, I figured is the smaller the ring I'm going to
Smaller
use.
the ring.
I don't think this duct system is very tight. Why am I making that assumption?
You see the leaks.
No. Yeah, I see a lot of leaks. It's pretty leaky here, so I'm assuming that the duct system is not very tight. Even though it's a small house, I'm going to try with ring 1 on. All right, so I'm going to set this up, config, ring 1. So configuration, it defaults to A1, A2, A3, C3. A1, B2, and C3. So I'm going to go to A1. All right, don't worry about the letter, but ring 1 is what I'm using. A1 is the corresponds to that.
Okay.
I'm set up, ready to run. And what does it say? Accurate measurement. Am I taking an accurate measurement? Only thing you can do now is fire it up and see what reading we get. So let's turn it on. And I'm going to let you guys just turn the light on. You guys hold that and tell me when I get to 25 pascals of positive pressure.
You're at 15 now. You're at 19, 20, 22.
That's close enough because I have it defaulting. I had 25, so it's gonna extrapolate that as if I had gotten 25. Same thing the blower door would do if I couldn't reach 50. So 22 is the same. So it's telling me what's my leakage number.
22,
Is it blank?
285.
Is it flashing or is it a solid number?
And it's a solid number, it's
So
285.
So that tells me I got the right ring on. It's not, I don't have to go to a smaller ring. So what is it, 225?
It's 287.
287. So that number, I would write that down, 287. And if you want, you can write that down. It doesn't have, it may fluctuate a little bit because you're going to be using a different machine. I mean, you're going to be using the same duct blaster, but a different one. It's probably going to be the same number when you come back. It's going to be the same duct system. So you're going to write that down. Even if it's not, something close enough is good enough. All right.
Well, wait a minute. Are we on step 56?
No, we're all the way down to step 106 right now, 105. So now it says leakage to outside, new ductwork. So only thing we have to worry about, we don't have to measure leakage to the outside. That's not required for BPI. But he does mention leakage to the outside limit. Now, this is my total duct leakage number. And let me just run upstairs and get my standards real quick. And I'll show you that it's not.
Alright. I'm going to close this. What's that?
Oh, this is yours, Chris?
Yeah.
Right.
You can use it if you want. I'm not
No, I
using
was
it.
looking
for standards.
Oh, okay.
Yeah. The outside. Just total duct leakage test. So, and the difference is, this is giving me the measurement of total duct leakage. It doesn't, but I don't know how much of this is going to outside, unconditioned areas. Since all of this ductwork is inside conditioned space, it's not really a big concern. I don't have much going in the attic. I don't have any ductwork in the attic, none on exterior walls I can see of, in the garage or anything like that. So I know that all of this ductwork is inside interior space here. But if it was ductwork going to the outside, you may be concerned. They give certain limits. The outside limit should be 10% of fan flow or 4 CFM for every 100 square feet of floor space. Let's say if you were at a house and you measured duct leakage to the outside, that is what you're looking for in terms of what's a good number or a bad number. But for purposes of our test, you don't have to do that. Duct leakage to the outside, just to go over briefly, I would have to hook the blower door up and pressurize the house to 25 pascals.
So it would be, the fan would be on the opposite side.
Yep, we're blowing air into the house.
Okay.
All right. This will still be doing the same thing, blowing air through the duct system at 25 pascals. But I would turn this up, and when I got my duct pressure, I would have to take this off of at 25 and just put it on pressure. And when I got the duct pressure to 0, I would measure that leakage to the outside. And why is that? If I measure let me ask a question. Whenever there's pressure difference or leakage between two spaces, what do you have to have?
Is there going to be a pressure differential?
Pressure differential or temperature differential. That's why we can measure draft with reference to outside and all, because we have temperature or pressure differentials. So when there is no pressure differential between one space and another, there's no leakage between those spaces because the pressure is the same. There's no leakage or pressure difference when everything is the same. So once I got my house pressure to 25, and got the duct pressure to 25, that number on my A channel would be 0, meaning that there's no leakage between the ducts in the house and the house itself. So any leakage I got on the B channel would be to the outside automatically, because where pressures are the same, there's no leakage between those two zones or areas. All right? That's the way you would measure, find out how much of this total 299 is leaking to the outside. All right? And there may be some leaking to the outside because of shell leakage and things like that. Maybe a little air escaping to the outside, but probably not much.
And that would let you be more precise with your guesses, like with the blower
Yeah,
door.
because I'm
this as a
concerned
backup.
about leakage to the outside, because I'm not getting the benefit. All the leakage now I'm getting the benefit of. Even though this ductwork is leaking down here in the basement, I'm still getting the benefit because I'm washing clothes down here. I come down, I have a workshop down here, so it's still heating this basement area. So I am getting benefit, even though it's leaky.
Well, we consider that a loss because this is outside an envelope. It's not even in an envelope because there's no insulation.
But I would look to bring this, based on the way the customer's using it, then my observation, I would ask the customer, how are you using the basement? My observation tells me you definitely wash clothes down. It's definitely a laundry down here. So you do spend some time down here in the winter. I see workshop. It was a workbench down here before, so I do know you do some work down here. So I would look to bring this into the thermal envelope.
So you're
I would seal up that opening over there where the Velcro doors are, and probably look to insulate.
So you're unintentionally.
Right now, I'm unintentionally conditioning the
the
basement.
surface.
I would intentionally condition.
How do we go about insulating this kind of space?
I would go with FSK, doing that fiberglass water heater wrap is like vinyl on the outside.
Yeah.
You can spray foam and then put up the walls, or I can go with FSK. Seal
Okay.
up all the openings and then put FSK around the walls.
Okay.
And bolt it directly onto the stone.
Okay.
And just leave it just like that. I wouldn't necessarily finish it because there's no need. This is not a living space.
No. Yeah.
But I would put the insulation on the wall.
What
And
would you do
then
on the floor?
the floor here, I would, because we talked about this, I would go with a vapor barrier and probably
Stone.
stone, and then put a walkway here of the air. See where this tile is? That seems
Yeah.
to be the designated.
Wouldn't we be
walking
concerned
area.
if we did the plastic of piercing it with the stone? Wouldn't that be an issue?
I would, but I think if we laid it down not too heavy, a fine, a crushed stone.
Yeah, or
we'd
use
pierce
the
it.
rounded kind.
Yeah.
Okay.
But definitely, if we walked on it, we're going to pierce and break it. So I would do that, and then put a walkway here, and they should be good to go. But definitely, this is all dirt floor, and that's cheaper than pouring concrete, I think.
Is concrete a vapor barrier?
No.
No, but you'd have to still have to put the plastic.
Plastic,
down first,
stone, then concrete.
and the concrete.
Okay.
Yeah. Okay, so we've done that part. So any questions on that? So let's talk about make appropriate duct sealing recommendations. What are they? We know that where's the most important part of the duct system to seal first?
Closest to the
Closest to the system. Why is that?
highest pressure.
Exactly, the highest pressure. So my priorities would be put a cover over that filter slot. My priorities would be to seal and fix this supply here. I mean the return. And then seal up any openings. Seal up that hole on the other side there. I would not use mastic around where the plenum top fits the system. I just use the cloth like you have it there. But mastic everything else. Take all the duct tape off, put in mastic, properly connect the duct. So you can walk around and just point out some areas that you see doing your test.
We recommend a bigger return or no?
Definitely, I would recommend more returns in the house as well. Inadequate returns, I would try to get a return up to the second floor if possible. So I would look for ways to add additional return ductwork here in the house. And I think if you can, probably figure out a way to get some return up there.
Now, would it be because there aren't any returns, you're pressurizing upstairs, which means that you're losing the heat because the higher pressure in the house is forcing it outside, right?
Well, ductwork, yeah.
The leakage.
Yeah. Oversupply causes the room to become pressurized.
Right.
To get leakage to the outside.
Right.
Too much return causes infiltration.
Right.
Supply causes exfiltration.
What you lose here, because this comes right to an end and goes up. And in theory, this right here should run a little bit beyond. It should have a backup pressure that pushes it up.
What, you mean the ductwork?
Right, for the ductwork.
Oh yeah, because you get turbulence. I can't tell you how much you lose, but you do lose because you're getting that turbulence right there.
So-
As the air, it should be a smoother transition. right there. So
Yeah,
it's
'cause there's
probably
hard
larger if I
squares
made that.
Right.
This should
The
actually
ductwork
go
is
beyond
undersized,
this.
so if I made that a
Because it
little bit
stops
larger,
here.
they give me a
Like this
circumference.
air turns
Like
on.
this
Yeah.
comes
And it doesn't
beyond, but it
go
doesn't
up.
come beyond
It's
far
easy.
enough for these to be
Yeah.
really
You mean like
efficient.
angle?
Well, no, this is good here because
Going
you see as it
further
reduces, that increases the air velocity. So as it reduces down, it's picking up
So
a
it's
lot.
extending beyond this, but still
Yeah.
go up. So,
So
they
this
can
is
exchange
good
and
here.
go up.
Well,
This is
what
probably
this
about a
does is
4-inch.
just walk like this.
So I might want to make it 6 inch, but I don't think I can get a 6-inch here.
You're saying this stays here.
Yeah, this I think is good.
Light sucks in here.
I'll wait.
Got a,
So there, yeah,
Hot lid
I would say
closing
so.
up
Yeah.
this trunk
You
here.
got a little more
Pretty high tech.
I thought you were
This system, it's oil, needs a
But yeah,
is it a baffle? No, it's not a baffle. What the hell's that thing called?
yeah, it should not. It should be come down. Yeah.
Oh, it's gonna come to me.
And so, and same thing here. This is just too small.
No, apparently
All
it's
the
not.
air is just hitting-
Tom, what's the name of this thing that's supposed to be here?
What?
The thing that opens up.
Oh, barometric damper.
Barometric damper is what this thing
Yeah,
needs.
exactly. So really, so you can
That's what
point
we're
out stuff
missing.
like that. You better return.
On that oil switch that's in here, which of course there's no light, the oil switch is going to need to turn on at 90 and shut off at 120.
Losing efficiency.
So in that lower left-hand corner, there's
Oh,
little
yeah,
switches on there.
definitely losing the comfort and efficiency. That causes the customer to.
I wrote all this stuff down for you.
They keep the system running more. They turn their heat up more.
Oil system, very leaky.
So they're spending
Smell of
it
diesel.
no matter what.
You need to check the lines. The lines are not fully fastened to the wall. Rusted. You can see a lot of erosion.
No, just stay out here and point out what we just talked about.
This is most likely the vent. This is most likely the
obvious
fill.
Stuff, definitely undersized, need more returns. Need a cover and a filter slide. Need to fix that. Like you said, the takeoffs here are short. It's causing some issues. The duct tape, all that. You got enough here that if you guys miss all this, then.
Hot water heater, not 6 inches.
So now, what else did we do? We got
from the
duct
ground.
glass, so we made
There's a
appropriate
valve.
recommendations. Methods
Use
selected
tank
for
wrap.
repair. We know mastic. We talked about some methods, things we're going to do. All right, now let's talk about comprehension of interaction of building envelope condition with duct leaks. We talked about that before. What's your name? Sorry, first name again?
Larry.
Larry. Larry and I just discussed that question right there. What did we talk about? Everybody remember? We just had that discussion.
Everything's inside. It's in the environment.
No, remember
on
we
the
said.
outside, right?
Remember we said leaks on the return side puts a house under negative pressure. Leaks on the supply side puts a house under positive pressure.
And if you don't have supply and return in each room, you get a problem because if the supply's in, but like we have upstairs, but not returns in all cases, what you're doing is you're pressurizing the rooms, which then leads to loss of heat through exfiltration, right?
Yeah. So that
And
answers
also
that question.
the fact that the heater then is
Yeah.
short cycle.
Mhm,
Because
exactly.
It's not getting enough return back.
And the room stays probably too cold. So what happens is the room becomes under for too much supply. You can only give it so much air in a room once the doors are closed, and it has no pressure relief. So you got to give it some type of pressure relief. So that answers that question.
And also, wouldn't it be that there's a possibility that this is problematic for the returns, which is affecting the CAS?
Exactly. That's in the CAS zone. So we can make that return slot a little bigger upstairs on the floor there, and probably try to add another one. So that answers that question of comprehension of interaction of building envelope conditions with duct leakage. Okay, now kind of answers now comprehension of building envelope with CAS zone. How does this leakage affect the CAS zone? What is too much supply return going to do down in the CAS zone?
Too much pressure on the return.
It's going to depressurize the CAS.
Oh,
Remember,
okay.
it's going to rob air from the CAS. But if this is too big with this open filter slot, it's going to start sucking the air from the CAS that the CAS needs, because it's going to suck the air back into the system, and my CAS needs that same air. So too much, this open return here is going to depressurize the CAS and may over depressurize it.
Is that a backdraft issue also? Or no?
Yeah, exactly. That's what's going to cause if it depressurizes too much spillage, because it has to get air from someplace.
Right. And then just
And it's going to pull it from the place of least resistance, and that's usually down the chimney. So that answers that question right there. Clear issue right there that's going to impact the CAS zone.
So not enough return makes it Positive upstairs?
Not enough return in the
Negative.
room.
Negative.
Yeah, makes
Negative.
it will depressurize the room, cause
Depressurize the
air
room.
infiltration. No, I had it back.
Yeah, right. He means down here,
That's
up
what I
there.
thought.
Not enough return means too much supply. That
much
causes
supply.
air to be pushed out.
So-
That causes
so it's
air to
pressurized.
leave. Yeah, it's pressurizing the room,
Yeah.
causing air exfiltration because it's causing the air is pushing out of the sidewalls. Too much supply is going to cause infiltration. It's going to draw in air from outside. No, too much return. Keep getting it backwards. Too much return is going to pull air from the outside because it's sucking. The house is under negative pressure. So it's going to get. Yeah, that's what we said, right?
Mm-hmm.
Yeah. Okay. All right. So now we kind of answered all that so far. We've gotten down to page 2.
So we don't have to worry, the way this is set up in here, we don't have to worry about confined space or anything, because there's a...
Yeah, that measurement. Yeah, we got more than enough room for
This
confined.
leaks, like I said.
Yeah, for
Okay.
he's talking about for your fuel
So we only have...
combustion because we know that to have combustion, what do we need for combustion? We need 3 things:
Air, fuel,
air,
fuel.
fuel,
Ignition.
and ignition source. So that's what he meant by combined spaces. Right.
So we only do total, we don't have to do to the outside.
To the outside, no, not according to BPI. You can talk about it if you want to. You can talk about it to the outside, but it's not that part of the test.
What are
is
we
not
comparing those
required.
numbers to? That leakage number.
You're comparing it to just what you get. Normally, you compare leakage to the outside. You compare it to the floor area. And
Okay.
It's a standard to leakage to the out. But this number, you're just trying to get a feel for what the leakage rate is.
So you'll do
There is. I gotta look and see if there's a standard, but I have to look. and
Yeah, I'm
see.
just wondering what we're comparing these numbers to.
I gotta look. I know the outside number, just so we're comparing it to floor area.
Will you repeat this after you, as a part of the test out, after you take care of everything
Yes.
here and see if it's dropped?
Okay.
If it's dropped.
Yeah.
I didn't know if there was like a airflow stain. You know how we come up with a
There is
PAS?
an airflow standard. I don't have it memorized what the recommendation should be, but I do know it's in your standards. And
It
I
is,
would
okay.
Go back to my standards.
All right.
And look at that.
It's a lot of information.
Outside, we usually look at 10% of system airflow.
Okay.
The leakage to the outside. Okay, so let's go to the next page. Now we're at the fun part now. CAS setup to create greatest competition for the chimney. You guys have all tested, so you're pretty familiar with how to do that, right?
Yep. Close all the doors, open all the doors
Yep.
upstairs.
So let's just kind of
Yeah.
talk about it. If you follow the sheet here, set up for natural conditions, wintertime conditions with pressure boundary closed. So what does that mean, set up for natural conditions?
Close all the
Close
doors
the
and
doors.
windows.
Yes.
Open the interior doors.
All
initially.
right. Next, proper manometer setup in the CAS with hose to the outside.
Can we can you just put the manometer in the way it would be for the test, just so I can have it on video? Like how it would be?
Where you're gonna set up manometer pressure in the CAS zone with what? What are they asking you to measure?
Outside.
Outside.
Pressure in the
with
CAS zone with reference to outside.
Yes.
So how are you gonna set this up? You tell me, since I won't tell me. How are you gonna set
Well,
that
with
up?
reference to outside, we could do it all in one channel, correct?
Well, that's what you're gonna do. Pressure in the CAS zone with reference to outside. So here's your hose here, and we made a hole over there by the window. So take this and set this up.
All right.
Yeah, I got you.